Okay. Hello, everyone, and welcome to Computer Science 2, MCS 2514 for the summer semester at Lawrence Tech 2022. So today we're going to go over the syllabus really quick and for first two chapters in the book. So I have actually 4 chapters. So I have the book in front of me. You should all have the book by now. But let's go over the syllabus. So this is my name, Professor Khalil Khalaf. This is my email. You can contact me through the email directly via Gmail or through Canvas. This is the period for our semester. It's going to be online. We're going to have 2 sessions per week, 2 hours per session. So that's 4 hours per week. I'm going to record videos like now. I'm going to post them on YouTube, and then I'm going to send you the link for that session. Office hours are by appointment since it's an online course. Contact by email, and you need to allow 48 hours for a reply. For example, if the deadline is 12 p.m. and then you send an email 11:30, you shouldn't expect a reply right away. I might be somewhere else. I might be teaching another course or my other jobs. This is the course title, Computer Science 2. CS2514, and this is the course book. It's called Starting Out with C++, and I have the Amazon link. Let me open it for you. Skip. So this is how the book looks like. Now, what I did in my previous life, when I was a student, I used to grab the older edition, but don't take it as a recommendation. Some people just can't afford. I couldn't afford books when I was a student, so I used to grab the older version, like this says 9th edition. 8th edition will work. It might be missing some changes, but not a lot. So back to the syllabus. We have the calendar in case you need to drop or check the important dates that we have through the summer. This is the calendar that you need for your reference. Prerequisites, of course, you need Computer Science 1 from LTU or Computer Science 1 from different university, it doesn't matter. Also, you need to know how to use Visual Studio 2019. If you have the current LTU laptop, then you're good to go. This is the course description. This is what are the main topics that we're gonna go over. So by the end of this semester, you should be familiar with functions, pointers, classes and objects, operator overloading, inheritance, polymorphism, templates, linked lists, dynamic memory allocation, stacks, queues, libraries, and recursion. In Computer Science 1, you're gonna notice in this course that we gonna go over same or similar topics that you covered in Computer Science 1, which is how the department wants it. The department wants Computer Science 2 students, whether they are from LTU or from outside LTU, to go over these topics, because some students from other universities did not go over classes, for example. So in this semester, we go briefly on intro to classes, then we dive into complicated topics that are related to classes, for example, inheritance and polymorphism. Objectives. Now, I don't want to read for you, just so we don't waste time. You can read it on your own. So these are the objectives for the course. These are, again, the main topics. And this is our calendar. So this is today, May 16th. Week 1A, we're gonna go over these chapters. I'm gonna assign you homework and project. Week 1B, 2A, 2B, etc., until we reach the final week. In the final week, we have a session for a review where I go over all the important topics that you need to focus on for the final exam, and then I assign you the final exam. Of course, the instructor reserves the right to make changes in this schedule when necessary. So throughout the semester, we might have changes. For example, this says homework 3 assigned on week of 23rd. I might assign it a day earlier or a day later, etc. It depends on the circumstances. The grading procedures. So this is where you score an A. This is where you score an F. And everything in between is based on this map. So 76 to 80 is C+, for example. For graduate students and for undergraduate students, they have a slightly different criteria. For example, for graduate students, under 66 or 68, you fail. For undergraduate students, under D minus, you fail. This is the grading criteria. We have 8 homeworks, 1 each. We have labs and participation, 9 points total for the entire semester. We have 4 projects, 2 points each. A project is a combination of 2 homeworks, if you want to think about it. We have homework every week, and we have a project every 2 weeks. So the material that we teach in 1 week, you get assigned a homework. And for the material that we lecture throughout 2 weeks, you get assigned a project. Also, I have the right to change when necessary. Student assessment, I recommend that you do the assessments whenever they post it. Of course, plagiarism, you're not allowed. And you can read all these on your own. Now I'm gonna go over to the book. So I'm gonna start with the book really quick. I have it in front of me, and I'm gonna open Visual Studio. I'm gonna create a new project. So create a new project. I'm gonna call it, let's pick, actually, no, it's not C++. I'm gonna pick C+. I'm gonna say I want on Windows project console. So this is the one, empty project. Next, I'm gonna call it my project. I'm gonna use this directory, and I'm gonna place both in the same directory. Create. Now that it created it, I have it as empty. So I'm gonna go ahead and do the first thing, which is I want to build and target 64 systems. I wanna add new item under source files. So new item. In this case, I want a CPP file, C++. So C++ file, and I'm gonna call it main, because this file is gonna contain the main function, which is the entry point for any program. So I'm gonna call it main. Here it is, empty. I'm gonna start with the basic one, IOStream, using namespace std, and then int main open return 0 cout hello world. Now that I include the IOStream, this will work. I run. It runs. Hello world. So close this. Now I'm gonna go by how the book does it. So whatever the structure that the book structured for us, I'm gonna go by it so we can all follow the same procedure. So I have the book on page 1, which is chapter 1, and it lists the topics. I'm not gonna read them for you, but I'm gonna go over the topics in this book really quick. Just a brief, because as I mentioned before, computer science 1 students should have already gone through these topics. So the first topic is why program. Why do we want to learn programming, or why do we program? Because computers can do many different jobs because they are programmable. That's what the book is saying. Basically, everything is computerized. That's why we want to program. Like if you want to pay your bills or shop online, think of social networks, think of computer games, smartphones, credit machines, MP3 players, cars. Cars have like 40 computers in them. That's a typical car. You can call a program a software. And software is essentially the computer, because a computer without software will not operate. Computers do nothing without software. And the program is written by programmers like me and future you, people with skills and talents and trainings necessary that they can design, create, and test computer programs. And after basically testing and releasing, you maintain the program. So this is what the topic is trying to tell you. It tries to explain why computer programming is both an art and a science, and they teach you each aspect of a program. They mention logical flow of instructions, because program is set of instructions and they have to be executed in order. If you have a set of instructions and you change then you change the order of them, the program will produce different results. It might even not build. Example, if I change the order of return 0 and I put it before the C out, the program is now different. This will return, that means it will not display anything. So a program is set of instructions and they have to be executed in a specific order. Then the next topic in the book mentions hardware versus software. So what's software? We just mentioned any program basically that you can't physically touch. That's a software. Everything in the computer that you can't physically touch is a software. On the other hand, everything physical in a computer is a hardware. And then they list the main components of a computer: the central processing unit, main memory, secondary storage devices, input devices, and output devices. You can review this topic on your own and ask me any questions if you have any questions. What is the CPU? What's the main memory? What is a secondary storage? What are input devices and what are output devices? And you are responsible for this topic. For example, if in the test I ask you list 3 input devices, you are responsible for that answer. So main memory, secondary storage, input devices, output devices. Then they start again with software, expanding on software. They tell you that you have system software, application software. Here right now in this course, we are 100% doing application software. We are not doing any system software. System software are like programs that run in the background. For example, if I open my task manager on my screen, I'm hoping you see my screen. Yeah, you are sharing. Yep, I'm sharing. So there are a lot of background processes. These are system software. Every service that you see in front of you is a software. Everything I have open is an application software. System software basically are within the operating system. They are utility programs that performs very specific tasks. Some tasks are to enhance the computer operation. Some tasks are to save data, privacy, protection, etc. Antiviruses, for example. And you have software that are tools for development tools. What I'm trying to say, for example, if I need to develop a C++ program, I need software development kits that are installed on my machine that support C++. You don't have to go in details for that topic. But you just need to know that there are system software and application software. So application software, they list and explain what are application software, which is basically everything we're gonna see in this course. I'm gonna write some code and then I'm gonna run. That application is an application software. The screen I see in front of me is a console application. Then in topic 1.3, they go over programs and programming languages, and they expand. Again, a program is a set of instructions that the computer follows in order to perform a task. a programming language is a special language used to write computer programs. So again, a computer program is a set of instructions that tells the computer how to solve a specific problem or perform a specific task. They give you an example uh, in steps 1, 2, 3, 4. First display, second wait for the user to enter, etc. That's a simple program. Then they go to programming languages. They try to explain that there are two main categories in any programming language. Uh, there are high-level programming languages and there are low-level programming languages. The one that we see in front of us, C++, that's a high-level programming language. High level means, if you can imagine it, this is, as a student, this is how I remembered it always. So I'm gonna open my paint for my amazing painting skills. You can imagine a human here and then a computer here. Imagine this is a computer. This is my desk, etc. So high level means it's close to the human being. It's understandable by a human being. If I look at C++ and I read include, well, that's an English language. It's a little easy for me to understand what this means. Okay, include, I'm including IOStream. IOStream, well, stream is an English language. IO means input output stream using namespace, main, int for integer, see out, cast out, return. So these are high level languages. They are easy to understand by a human being. However, on the other hand, you have low level programming languages, languages that look like these bunch of ones and zeros. This is very hard for me to understand as a human, but it's very easy for the computer to understand. In order for the computer to understand my high level language, it's gonna go through a lot of processes. And this is what Visual Studio job is. Visual Studio's job is to take my high level programming language, convert it, combine it, link it together, and then provide it for the computer or the CPU as specific instructions that the CPU can understand, ones and zeros. So again, back to the topic with the book, programming languages are within two main categories, high level, low level. Then they list examples on page 11 of high level programming languages, C++, C Sharp, Java. Now, how much do you think there are out there? How many programming languages do you think? You think it's 50, 100? How many programmers are there? There is a lot. According to 20th edition of there were 6.8 million. These are developers. I'm not asking about developers. How many programming languages are there? Yes, there are over 300 programming languages. I bet you there are more. Maybe 300 are the popular. There are programming languages that nobody know about them. And there are programming languages that were a concept, just to prove a concept. Someone made their own language, and it has a hello world. For example, this language was just a proof of concept that you can write your own language. For example, this does simple addition. This is a program, plus plus, da 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 da. This displays hello world. So it was just a proof of concept that you can build or create your own language as long as the language follows the rules. Every language has rules. If I go on my screen right now, if I go out of the rules, then the program is not going to end. Why this is, why I have an underline, red underline under this user defined or programmer defined word, because it doesn't end with a semicolon, and this variable is not declared. So there are rules that I need to meet There are conditions or rules that I need to meet in order to satisfy the language, and then it builds. We will go in details further on this topic, but to follow with the book again, they list some of the popular or maybe most popular languages. Then they dive into IDE. What is an IDE? Visual Studio is an IDE. IDE means Integrated Development Environment. What does it consist of? It has text editor, a place where I can type my text, and it has colors into it that can help me develop. For example, everything literal is in brown. Everything, all key or all reserved keywords for the language are in blue. I cannot create a variable and call it namespace, because namespace is a keyword that is reserved by the language. So IDE has text editor. It has IntelliSense. IntelliSense, which is this. You see this pop-up menu that suggests based on what I'm typing. So that also is part of the environment that helps me develop. So again, IDE, Integrated Development Environment, has a text editor. It has IntelliSense that helps me program, basically. Then finally, it has a compiler. Compiler means takes my text, converts it to objects, then link all those objects and compile them into an executable file. Then the executable file is just like any executable file you see. Whether I click remote desktop, it executes the program. So an executable file is a file shortcut to the program. For example, this icon here is a shortcut to the program remote desktop. When I click on it, I execute that file. So someone wrote an application called remote desktop, and when that program executes, it pops up this menu that has this on it, you know, like a title, header, image. It has a label, drop-down menu, another label, info, button. So that's what the program does. In your case, it's the same. If I go right-click on my project and I say open folder in File Explorer, I'm gonna see a folder called x64. Why? Because I already targeted x64. So when I build, it creates a folder called x64. When I open that folder, I can see my executable file .exe and bunch of other stuff. Don't worry about the other stuff, but this, when I double click on this file, it's gonna execute this program that I built here. Whatever I built here, I can execute it through Visual Studio, or I can execute it as just any executable file on Windows. So if I double click this, it's gonna display, oh, it closed fast. So let me pause it. System, pause. Now, if let me build it so we can have a new executable. So now that I built this 431, here it is 431, and I open it, it says hello world. So this is just the program. While if I execute it from Visual Studio, you know from Computer Science 1 that you can debug your code and you can step through your code. So the difference between an IDE and just executable the file is basically diving into the code while the program is running. I can break point, I can start. Now the program is running, but I am also looking at the code step by step. So that's part of the IDE as well. That gives me insight into the code and allows me to step through the code. So that's page 11. 13 as well tells you everything about an IDE. Then it goes to topic 1.4. 1.4 says, okay, what is the program made of? Well, the program made of, there is a table actually, table 1-2. So program made of keywords, programmer-defined identifiers, operators, punctuation, and syntax. So keywords like using, namespace, include, int, main. These are keywords that are reserved for the language. I cannot use them. The next one is programmer-defined identifiers. Programmer-defined identifiers are variables that you create. For example, int my variable equals 1. This is a programmer-defined variable. It's an identifier that was created or defined by the programmer. I can call it whatever I want, as long as I don't use the reserved keywords. Now, my variable, it's called a variable because it can carry or hold or store different values. At this point, at this line, it's gonna store the value 1, and on some different line, it might store 10. So it's a variable. The value in it is variable. However, on the other hand, this character 1, the way it's written, is gonna always be equal to 1. Whatever I do, this way is always equals to 1, similar to this way. 10 in this, the way it's written, will always mean 10, will always equal 10, unlike my variable. So these, my variable and any variables that you create, are programmer-defined identifiers. Then you have operators. Operators are the mathematical operators. Basically, 10 plus 1. So this is an operator. Also, this is an operator. You have operators throughout your program. This is an operator. Yeah, then you have punctuation. Punctuation are, for example, open, close parentheses, open, close curly braces or curly parentheses, semicolon. These are punctuations. Then last thing is syntax. Syntax means the grammar of the language, the rules. For example, this has no underline, red underline, because it matches the syntax. It follows the rules for the C++ grammar. For example, in the English language, I cannot say I were at the store. This is wrong statement or wrong sentence in the English language. Why it's wrong? Because it doesn't match the grammar. I can't use plural with a singular. If I use I was at the store, now it's correct sentence because of the fact that it matches the grammar of the language. Similar fashion, C++. C++ has some explicit rules for its grammar, for its language, that you have to meet in order to build your program. The fact that I have a C out, then an operator, then a literal, then operator, then end line, makes it correct and legal. If I have C out without the operator and then a string, that's illegal. It doesn't match the grammar. So the language is made of keywords, programmer-defined identifiers, operators, punctuation, and finally syntax. Then we go to section 1.5. Section 1.5 says, okay, every program has main primary activities, 3 primary activities. Every program will have some input, will does some processing, and then finally outputs some result. Every program, whether it's a system program, system software or application software, every program will receive some data, will do some processing, and will produce a result. That's what basically they are trying to say. Then they go to section 1.6, the programming process. The programming process starts by designing your software, designing anyway under the hood. So designing the algorithms. If you have complex problems to solve, you're gonna think of the solution before you start implementing the code. For example, oh, I need to sort first and then do that. So you need to think of all these roadblocks in the back end. You also need to think of all the front end, how your application will look like, how the user is gonna enter the data, How is the flow gonna go? Hey, do I ask for the first name first or the last name first? What do we do first, then what? Just like a mobile application, you click a button, takes you to a screen. Then you click another button, goes to the third screen. So, and anytime you develop a software, you need to think of the screens. Which screen comes first, and what do I have on the first screen? Then, which screen comes next, and what do I have on that following screen, etc. And they have steps for writing a program in brief, figure 111. And this is it for chapter 1. Finally, they speak about software engineering, which is not just development. A software engineer does not sit on his computer 8 to 5 just writing code. There are much more into software engineering. You have meetings, you have designing, you have meeting the customer, you have gathering requirements, you have designing on a piece of paper on the whiteboard, you have designing the algorithm, thinking about it, not just implementing it. Once you're done with all these steps, then you sit and do the coding. After you've done the coding, then you have the testing, the unit testing, the integration testing. Then finally, you have the release and version control and documentation. And after that, you have maintenance, upgrading a software or upgrading a feature, fixing a bug or adding a feature. So there is a lot into software engineering, not just programming. Then they explain briefly what's object-oriented programming, which is what we're going to learn in this semester. I'm pretty sure you learned about classes briefly in Computer Science 1, but they are trying to show you the difference between the old style, which is procedural languages, and object-oriented programming. Object-oriented programming is the most popular now, and every popular language follows object-oriented programming, because object-oriented programming reflects real-life situation. Everything our real life around us is objects. I am an object. I'm an object. I have a name, I have height, I have a size, I have I have other objects in me. I have a shirt, I have a pants, I have shoes. Even the shoes has different object in it. So everything is objects. And in C++ or object-oriented programming, the whole software revolves around objects communicating with each other, objects calling other objects, while in the past, procedural programming was function communicating with another function. So functions communicating with different functions versus objects communicating with different objects. And that's chapter 1 pretty much. So now for chapter 2. For chapter 2, I'm going to go ahead and type program 2-1, which is page 28, just so I explain exactly how the book is explaining it. So a simple C++ program. Then it has the include, it has the using namespace, this and that. It has this, it has that. Save. So the parts of C, that's how the chapter starts. The parts of a C++ program. C++ programs have parts and components that serve specific purpose. Good. So what they are trying to say is every C++ program has parts. They might not be in the same place, but they are there and they have to be there. So your first step in learning C++ is learning those types or those parts of a program. The first part is first part in our humble program is this comment. The fact that I have two forward slashes makes it a comment, means the compiler, when I hit run, is gonna ignore this line. It will not compile this line. And this line, no matter how much I type here, is not a syntax error. It's just ignored by the language. And the editor, IDE, Visual Studio, colors it in green to help me differentiate between comments and other lines. Then we go to include IOStream. The book does tell what include is. include the fact that we have this hash in front of it makes it a preprocessor directive. It's called preprocessor directive, and it's called preprocessor directive since the first thing the compiler does is looking at the preprocessing directive, which library or which file I should include into this file before I compile it. This IOStream goes along with cout. If I don't have this line, then the program will not know, hey, what did you mean by cout? You didn't declare a variable called cout. So the fact that I included IOStream helps or tells my program what cout means. And it's called a preprocessing or preprocessor directive because it gets processed first thing first. The first thing that the compiler looks at when I hit run are the lines that start with hashtag, which files to include so we can build. Then we go to the second line, using namespace. Using namespace std, which is standard, right now I'm using the standard namespace. In general, programs usually contain several items, like variable and stuff, and with unique names to them. However, those unique names are within the namespace. So I can have two objects with the same name, but each must be in a namespace. If I have object A under namespace as namespace A, then I can include namespace 1 and then use that object. The compiler will know which object I'm talking about because it's under that namespace. However, if I have the same object name in two namespaces, I cannot use both namespaces because at that point there is a conflict. The program will not know which object did I mean. Did I mean the object from space 1 or space 2? So right now I'm telling it, I'm just using the standard, whatever comes with the language. It's not my own, and everything I declare in my program are going to be unique within the standard namespace. Then we go to line number 5, int main. This marks the beginning of a function. In general, this marks the beginning of the of a function. In this case, it's the beginning of the main function, and the main function, like this, specifically lowercase. The main function in C++ is the entry point of my program. This is what the program is gonna start from. When I run this program, it's gonna start by executing the lines in this method. Then we go to the open curly braces. This is the beginning of the function body. So this is the function header line or function definition, you can call it. And this is the function body. This is the beginning of the function body. This is the end of the function body. We have this line. This line is simply, if you want to put it simply, it displays on the screen. This displays hello world on the screen. Then we go to 2.2, the cout object. Again, I'm assuming that some students didn't come from Lawrence Tech, so they don't know what cout is. But they are responsible to read the book. If you guys, everybody, if you want to score A, read the book. Everything I do in this semester is based on the book. I go by the book throughout my lectures. The homeworks are whatever we did from the book. The projects are whatever we did from the book. And the exams are for whatever came from the book. So you are expected from you to read the book topic by topic. You don't have to absorb every sentence from the book, but you are responsible for each of the topic. Topic 2.2, the cout object. You want to skim the section or read it in details, that's up to you, but you are responsible to know what a cout object is. So cout object, what is a cout object? This is the cout object. It's an object to display information on the computer screen. Whenever I call this object with this syntax, then it displays a sentence on the screen. And they give you examples. Then they mention the escape sequences. Escape sequences meaning, look at this example. I have cout operator, double quotation, hello world, exclamation mark, double quotation, and end of the statement. So these double quotation marks indicate that I'm trying to display what's in it. When I run, I'm not gonna see double quotations. Double quotations are for the language to know what I mean. However, what if I need to actually display double quotation? If I wanna display instead of exclamation mark a double quotation, now I'm confusing the compiler. Like, hey, what the compiler is saying, hey, what did you mean? Okay, you opened double quotations, you closed it, and then you have double quotation. This is illegal. So in order to escape that rule, we have escape sequences, and that is using the backslash. If I need to display a double quotation, I append it with a backslash. Now that I have backslash double quotation, then it's gonna actually display the double quotation. So by doing the backslash, I'm telling the compiler, hey, you see that following character, escape from the rule and just display it. So I have this example. What if I need, right now I have this, for example, the letter N. In C++, backslash N is a new line. So in order to see it, instead of the space, I'm gonna say new line. If I run, now it's a new line. This backslash N is a new line. So what if I actually need to display backslash? Hello, Noreen, a person called Noreen or Noel. So what if I need to actually display the backslash? I don't want hello OL. No, I need to actually display backslash Noel. In this case, I double the backslash. So now this backslash telling the compiler to escape the rule and just display the following backslash as is. Now I'm gonna get a backslash. So escape sequences are in the book, table 2-2, page 35. I'm not gonna type them in front of you to waste your time, but they are in the book. So following the book, they speak 2.3 include directive. I'm not gonna dive into details. You know enough about include directive. Then they go by variables, literals, and assignment statements. We know what a variable is. A variable is anything that I define as a programmer, and I can assign it any value I want. For example, int my variable equals 10. This is variable. Variables, I'm reading from the book. Variables represent storage locations in the computer's memory. Literals are constant values that are assigned to variables. So this is a literal. It's literally 10, no matter what. Similar case to everything between double quotations. Anything between double quotations is literal. Even if I move my variable, which is a variable, into the double quotations, it's no longer a variable, it's now literal. It's literally ma, my, va, there is no value in it. It's not storing any value. It's whatever literal meaning it has. If I run now, notice it displays my variable literally. However, if I remove the double quotations, now it's the variable which is carrying 10. If I run, it's going to display the value in that variable. So the 10 in this way is literal, and anything between double quotations is also literal. So that's what the book is trying to say in this section: variables, literals, and assignment statements. This is the assignment statement. They go to the literals, then identifiers 2.5. Identifiers in your semester, on this course, identifiers are variables. Consider them variables. Identifiers is a big umbrella. Under it, variables. There are enumerators, and there are a lot of syntax that you can put under identifiers. In brief, what the book is trying to say is identifiers are variables or labels or storage or that you pick the name. You are free to pick the name. You can call them whatever you want. So those are identifiers. However, the book lists all the C++ keywords that you cannot use. So page 42, table 2-4, these are all the keywords that you cannot use. With experience throughout the semester, you're gonna get enough experience to know which keys or which words you cannot use. So in the test, when I ask you to list 5 C++ keywords, you will be able to list 5. But this is the table for all the keywords. Then table 2.6. Table 2.6 goes over integer data types. What are the data types of an integer? Any integer number, there are different data types under the hood. There are many different data types actually. So variables in general are classified according to their data type. You know, like the compiler needs to know how much memory I need for this variable and what kind of information it's gonna store. It's gonna store. These two pieces of information the compiler needs to know what to do. It needs the data type of my variable, and it needs basically it just needs data type for two reasons. One, how much memory it needs in the system, and what type of info it's gonna store. So forward to page 44. Integer data types under table 2-6. You have 8 in general for integers only. So you have short int, and you need to know the size. You don't need to know the range, but you need to know the typical size in bytes. So short int, 2 bytes. Unsigned short int, also 2 bytes. You have basically 4, but 2 for each. So you have short, but you have signed and unsigned. You have int, both signed and unsigned. You have long int, both signed and unsigned. You have long int, both signed and unsigned. Signed and unsigned means negative or positive. So I have 10 minus 10. So this is sorry, no, not that. Signed and unsigned means if I say int, then this variable can store negative and positive range. It has range. For now, imagine the range is minus 1000 all the way to 1000. The fact that this is signed means it can carry either negative or positive. If I tell my compiler I need an unsigned int my variable 2 equals whatever, this means the range is only positive. It's unsigned. There is no sign to it. It's only positive. Means if this range, if integer variables or integer, sorry, data type carry 2000 range, right? From minus 1000 to plus 1000, that's 2. The range is 2000. Then unsigned int is 0 to 2000. Only positive because it's unsigned. There is no sign to it. So assume there is a plus always. Since it's unsigned, means there's no negative. So back to the table, we have short int, long int, long int, and you need to know the size in bytes for each. Shorts are 2, integers are 4, long ints are 8, long int are 8 as well. The book shows 4, but it's rare to find a system where long int are dealt as or stored as 4 bytes. For example, an example of unsigned int is a grade. A grade, it cannot be negative. There is no way that you score minus 20 over 100. It's either 0 or above, just like counting. No matter what the count is, it cannot be negative. If I give you a box and ask you to count the apples in that box, what's the possible range of values that you're gonna come up with? It's either 0 or 10. So it's based on your logic or the logic of your program, you either pick signed or unsigned. If you pick signed for something that is only positive, then you're gonna lose half of the range. Half of the capacity will be lost. Then they go to, if you plan to continue on computer, do we have time? We can create time. So they go by hexadecimal and octal. Hexadecimal is, let's go back to Paint. So hexadecimal is in our daily life, we have a set of numbers, and then every number that we know is a combination of that set. The set is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Every number we have, whether it's 1000 or 9000 or minus 10, whatever, it's permutation of this set. Every time I reach the end of this set, I increment 1 and then start over. For example, 0 to 9. I reach the end of this set. Then I increment and add 1. Then I go again, 1, 2, all the way to 9. Once I reach the end of this set, then I increment and I start over, 0 to 9, or 20 at this point. Then 39, so 0, etc. So every time I reach the end of the set, I'm repeating myself. This is a human being. Then we have hexadecimal. Hexadecimal is how the memory stores its value, and this is base 10. The set is 10 numbers, so it's base 10. Hexadecimal is base 16. So in its set, we have 16 choices we can call, 0 to 9, and then we have A, B, C, D, E, F. This is the set for hexadecimal. So in hexadecimal, just like how with a human being, you can see 1, 2, 9, 0, 4, 6 as a number. In hexadecimal, it's expected to see 1, A, 2, F, C, D, 5, E. This is a number in hexadecimal value, and it's base 16. And then they have octal, which is base 8, so 0 to 7 only. 0 to 7 only is octal. So basically, you go by 1 to 7, and I reach the end of my set. Then it repeats itself. 0 to 17. I reach the end of my set, then it repeats itself, etc. Base 8, octal. Then they speak about the char data type, topic 2.7, char data type. Char data type is a data type that stores only one character, A, B, and it is between single quotation. So anything you see in C++, single quotation is a character. Anything you see within double quotations, it's a string. Here, this is a string, which is a group of characters. If I have a char data type, then I have to give it as single quotation. If I give it as double quotations, it's a syntax error, not allowed. It says, hey, you're trying to assign a string to a character. So a value of type const char pointer cannot be used to initialize an entity of type char. This is a const char pointer. So it's pointing to a block of memory that is constant, literal, it can't be changed, and it's an array in the system. The fact that I put double quotations, I created it as an array or a pointer to group of characters. You're gonna learn more. So the point is character data types only store one character. And notice the value 1, let's display my variable. In this case, I'm gonna say 67, or let's do 9. Take this out, take this out. My variable is 9. This 9, I'm not storing the character 9 because I didn't put single quotations. I'm grabbing the value 9 from the ASCII code table. Whatever that character is will be set or assigned to my variable. ASCII code table value 9 doesn't show, so maybe it's not displayable character. Let's try 5. So this character is the cards character. So it's not the character 5, it's the value 5. If I go to my Google and I say, show me ASCII table, ASCII code number 5 is, doesn't show me, where is it? So 5 char, E and Q. Well, E and Q is what we saw when we display. We can do, for example, 43, which is the plus character. So 43. Now it's going to display plus character. Here is the plus character. So again, 5 will grab the value 5 from that table and display it. However, if I wrap it between single quotations, then it's going to carry the character 5. So now if I display it, it's the character 5. So that's all about char data type. Then they go to differentiate between string literals and characters. So as I mentioned, this char will store single character. And it's important to know how this is stored in memory. This is stored in memory just like that. I have blocks in my memory, and it's sequential. Memory in computers are sequential, meaning it has a bunch of blocks like slots. Let's call them slots. Right, bunch of slots. Imagine a street with buildings. This address is 0. This address is 1. This address is 2, 3, 4, etc. So every slot has an address. When I say char my variable equals 5, then the compiler is going to go to the operating system, asks for some available or free memory. Then the operating system is going to go, oh, well, you see this address, let's say it's 13, whatever. You see this slot, it's empty, and it's 1 byte each. This is 1 byte each, and characters are 1 byte. So I have this slot empty. Here you go. So operating system brings back the address and gives it to my system. Now my variable has the value or the character 5 in it. So it's gonna go and put 5 in here. So this is how a character is stored. However, a string literal like this, for example, this is stored different. String literals do not have fixed size. It can be 5 characters, 15 characters, 25 characters. We don't know. It depends, right? It depends on the circumstances. Maybe the user entered it. We don't know. This, I'm not going to introduce pointers now, but imagine this points to the beginning of the block. When I do this, the compiler is going to go to Windows or operating system. It's going to say, hey, I have a string of X X characters and I need memory for them. Then Windows is going to say, oh, I have here is some free slot. How many characters did you say? The compiler says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the Windows says, oh, okay, 10. Then here is 11. Here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the compiler, the operating system always stores one additional slot for string literals. And this last slot will have 0 in it. 0 is null. So the difference between literal characters and string literals is string literals have one additional slot, one additional byte, and that byte or that slot has null in it. And this null indicates the end of the string. So that's why string literals are called null terminated. They are terminated by a null. So any string that has n characters, its memory is n plus 1, because there is always one secret terminator at the end of it that indicates the end of the data. That's what the book is trying to say, and there is a good example on figure 2-5. Then we go to floating point data types. Floating point data types, we have single precision, we have float, single precision, we have double precision, and then we have long double precision. And you need to know the sizes of each in bytes. So float is 4, double is 8, and long double is 10. Yep. So we have a float. The floating point means decimal. So I have int, my var equals 10. Then I have float, my float equal 10.5, for example. So floats store decimal part along with the whole part. What do you need to know about these? You need to know the size. You also need to know that if I assign float or decimal number to an int, the decimal part will be lost. If I execute this statement, then my variable is going to hold or carry or store 10. Notice when I display, it's only 10, not 10.5. Another thing you need to know about float is the notation. I can use this notation or I can use the scientific notation. For example, I can say 1.05 E2. Run, actually, let's display it. What is it doing? Is it that hard? Float my point, this, yeah. Okay, here it is. Yeah, I needed to click something. Why I needed to click see out this and that. I don't know why it expected an input. Anyway, I can use the scientific notation or the normal notation. What else do you need to know about floating point? Yep, the assigning floating point values to integer variables, you're gonna lose the decimal part. Then they go to the bool type. Boolean is a data type, bool, my bool, that stores only one of two values. It either stores true or false. Imagine it's a switch, on, off, true, false, yes, no. So I can either put 0 for false or anything else for anything for true. So if it's 0, then this is false. Anything else means 1 or 10 or 100 or 1000, then it's true. 0 is false, 1 or more is true. That's another data type. Then 2.11, section 2.11 speaks about determining the size of a data type. How do I determine the size of some variable in code? Let's say I have int my variable equal 1000. Then I can display size of my variable. This method is gonna display in bytes the size of this variable. Since it's an int, then it's 4. Here it is, size of integer is 4. I can say, for example, double. What is the size of a double? It's an 8. Here it is, size in bytes. Later, it's helpful when some function receives an array. Then I can call size of my array, and it's gonna give me the size in bytes. For example, imagine you receive an array of characters. Every character, we know that every character is 1 byte. So when I receive an array of characters, I can run size of the array. The number of bytes means the number of characters. This way I can iterate up until that number. Then the book speaks about arithmetic operators. Arithmetic operators are the math. So plus, negative, division, and multiplication. One note is multiplication is a star, is not X. So you have plus, subtract, divide, and multiply. These are the arithmetic operators. What else do you need to know here? Also modulus, sorry. Modulus, which is the remainder operator, they call it, remainder operator. Remainder operator is the remainder of any division. For example, 10 example, 10 remainder 3 should be 1. Why? Because if I take all the 3's from the 10, I'm left off with 1. So that's the remainder. 1. 2 remainder 3 is 2. Because I can't take 3 out of the 2. So this is an operator as well, arithmetic operator. And it's very fast, very helpful. For example, I can figure out if a number is even or odd very fast. If I have any number, 1, 2, 5, 7, well, by looking at it, because I'm a human being and I have common sense and I'm smart, by looking at it, I can tell right away that it's even or odd. But computers are stupid, and they have to go through a procedure to figure out things, right? They need to go through some set of instructions in order to solve a problem. So for the computer to figure out if this is even or odd, it has to go through a process or a procedure that a programmer wrote, or I can run modulo 2. If I take off all the 2's from this number and I'm left off with 0, that means it was an even number. If I take all the 2's and I'm left out with 1, that means it was an odd number. So since the display is 0, that means that number was even. If that operation returns 1, that means it was an odd number. And it happened very quick, if you notice. Well, computers are quick right now, but this operator is very quick. Then they speak about integer division, and you need to know about that. Integer versus over integer, for example, 11. 11 over 2 is what? 5.5. When I display my variable, notice it's not going to display 5.5. I lost the decimal part. Why? Because integer division. Integer division results in an integer. Since I'm dividing integer over an integer, the result of this operation is an integer. Then I'm grabbing the result, which is an integer, and assigning it to my variable, then displaying it. This is why I lost the decimal. In order to receive the actual floating point result, one of them needs to be float. So 11.0, for example. Now that this became float or double or whatever you want to call it, now since this became a float over an integer, then it's no longer integer division. That means the decimal part will not be truncated or lost. So now when I run, it's going to display 5.5. So you need to be very careful in your programs or homework or project or test. Whenever you do integer division, you're going to lose the decimal part. Then the book speaks about comments. How do I do comments? This is one way, and this is only one line. So if I hit enter, now I lost the comment. So this is a single line comment, or I have a block, comment block. And I think inside this is going to be a comment, even if it's on a separate line. So two types of commenting. This is one part, one way. This is another way. And this is it for chapter 2. So I'm going to take a break and then go over chapter 3 and 4.